All right, we are now back, and we have gone over quite a lengthy review of what it is we would like to make in regards to our game engine for the Hyperion Project. Well, it's time to get started and write a little bit of code. So here we go. For those of you that have never done this before, take a deep breath and carefully follow along. Listen carefully to what it is that we say, and we'll jump back and forth between Photoshop with the document that we created in the last lesson, try to help keep everything as clear as possible. But again, this is just to give you an idea of what it's like to program a game, not to get into teaching you the specifics of the language yet. That's to come. So Logan, let us create our project.
Well, we need to begin with our new project. So File, New Project, will bring up what we want.
And just sitting right here, look at all these things we can make. A Windows application, a class library, just a console application, empty project. Ooh, we have kits, like a screensaver kit. There's some other kits. Trust me, they're there. It's like the Space Wars kit. We got, Xbox 360 game. All sorts of neat stuff that we can create, and we're going to be talking about, well, quite a few of these things as we proceed through the entire XNA Xtreme 101 class. But for starting everything out, we're going to start as simple as can be, and that's going to be with a console app. And what is a console app? It's like, when you guys run command prompt, and you're not dealing with Windows and all. You're just dealing with a console. And so our app's going to be self-contained within that console.
Right, it's just a very simple way to see text and input text. So text input and text output.
Exactly. After we get done with this one, we're going to move over to the world of Windows applications. And we're going to write a couple very simple games that are going to be Windows-based. And then from there, we'll start working our way over into creating Xbox 360 games through XNA. So that's kind of the plan. Let's start simple. So here we are, console application. We need to go ahead and give it a name.
And the name of our game and engine, we're calling this the Hyperion engine and Hyperion game, so the project name can simply be Hyperion.
Okay. And we click OK, and all sorts of stuff comes to life. Now, I know we have not yet taken a trip around the user interface. That's coming. Like I said, I wanted us to get in and get our hands dirty fast. So right now, what you're looking at is some code. You're looking at the heart of your program. I mean, we actually have a program. We can run this program right now. Run it, Logan.
All right.
Watch carefully, guys. He's going to hit the little play button, and boom, boom. That was it.
Well,
exciting, eh?
That was a quick program.
It didn't have no problems, thank heavens. It did indeed run. But, in this case, generally most people do a little Hello World type thing. And what we saw all the way back over in our documentation, as a matter of fact, just to remind everybody, let's go ahead and jump back over here. And I believe it was, let's find where the mouse is. There it is. It's really hard to see. One of these guys right here said the first thing is going to be the show title screen. So how about we start something like that? We start with a show title screen, but let's just echo out something like, welcome to Hyperion or something. So that's going to be our title screen.
Well, like you said, we want to output something, so we need to access the console since that's where we're outputting to. And we're going to tell the console to write out a line. And we want that line to contain the following text. This could be, welcome to Hyperion.
Now, Logan's done very little here. You'll notice that the one thing he did do is he didn't go in there and start messing up or deleting all the code that was already in place. When we start a new project, fortunately, we've been handed a framework to work from. Even better, C#, of course, running on .NET. The .NET contains thousands of these objects out there that are already pre-built that we can use. And this is something we'll be exploring in much greater depth later. But Logan's doing that right now. He's using the console object. That's an object. And he's calling upon the method within the object. He's calling upon WriteLine. This is no different than earlier when we took a look at TVs and DVD players and all that stuff, where we could have said TV1 dot turn on power, or turn on, right? Or remote dot press button. Well, here we are, console dot WriteLine. And the console object that's built into .NET. It's already there for us to use. And you know how we can use it? Look at all these usings up above. Just highlight all of them to begin with. All these usings are in place. These are containers pointing to all sorts of objects that are out there. And as we progress through this course, we're going to give you guys a much better understanding of where you can find these different containers filled with lots of great objects for you to add into your application. You know, the whole idea is Microsoft wants to keep you from having to reinvent the wheel over and over and over. It's one of the beautiful things about object-oriented programming. So it's there. So we're using these things by default. We have access to the console. And so Logan's got that in place. He's put it inside of the static void main method right there. So this is where our program will always start, right here. So that's where it's going to start. So when the program begins, the very, very first thing that's going to happen is it begins right here. This is what we're going to run, okay? Now, technically, it is far more involved on how .NET works in regards to compiling and assemblies and how it's actually executed. For those of you that know a little bit about that or even a lot about that, that's outside the scope of what I'm wanting to do in regards to getting our beginners' hands dirty. We'll come back to all that stuff later. Right now, it's all about let's write some code, make something happen. So Logan's got some code in place, but if he runs, it's still not going to look pretty. Wait, that was so fast, Logan, I didn't have time to read it. Could you please do that again? Oh, it's just too fast. Right now, what's happening with the program? Well, it's starting out right here. It's echoing or writing that line of text out to the console, but what happens next? There is nothing next. That little curly brace right there concludes our main method. We're done.
Right. A console app is very linear in how it executes. We enter main, we begin doing things, and then main ends. With the end of main comes the end of our program. That's right. Why it's exiting after it hits the end of the line.
So, Logan, can you prevent this from exiting right now?
Well, we simply need to do something that will take a noticeable amount of time.
Okay.
And the best way to do that is to have the entire program wait on us.
Oh, okay.
If we tell it to ask for input, it's going to wait until the input's entered. So let's again ask the console to get some input. Let's tell it to read a line, which means give a prompt and wait for us to enter something and press the enter key. So read line, and I'm not going to feed it anything. Just read line, tell it to wait, and get input.
So it's just waiting on us.
Exactly.
We hit it. Ah, hello to Hyperion. And it's just waiting. Waiting for us to hit anything. So hit a key on there.
So if we hit some keys,
yep,
it's basically allowing us to write a line, because that's what we told it to do. We told it to read a line.
Read the line. Now hit enter. He's got the line. It's done. Okay? He wrote a line. Not a character. A line. Not a key. Later on we'll do press any key. Right now, a line. All right, very cool. So here we are. We're starting off in main. We've written something out. Very nice. Is this how programs look? No. This is not how you want to code things. I want the code inside of main to be very, very, very simplistic. I mean, in the end, we're just starting a game. We're initializing it. We're getting it rolling. We're looping through their commands. It's very little. You guys saw the program flow. There's not much to it, is there, Logan?
Right. There wasn't anything about get one line of input. It was never part of the original program overview.
Exactly. So, where does our title screen need to go? Because that's basically what he's got here. Welcome to Hyperion. That's going to be our welcome to our title screen for the game. Where does that need to go?
Well, we could put that in the game manager.
Okay. Now, for those that are wondering, well, how do you decide that? Well, let's come back over here to Photoshop real quick. Let's go ahead and hide that. And there's all the objects that we're going to create. Where is the most appropriate place in all the objects that we're going to be adding into this program of ours? Where's the most appropriate place for it to go? Level? No. Rooms? Items? Player? No. Game manager. He's managing the game. We're going to show the title before we start to... That works for me. So let's make a game manager and move that code out.
Okay. So in order to make a game manager, what we're going to do as a general practice is we're generally going to put one class per CS file within our project. And as a matter of fact, before I even get to the file itself, I'm going to add a folder into our project to hold all of these classes, so we have one convenient place where all classes go.
Yeah, Logan's a big-time stickler when it comes to organization, which is good.
So this Hyperion, this is our project. If we right-click on it, we can add things, and one of the things we can add is a folder. So I'll click on New Folder, and we'll call this folder Classes. Now, inside of this folder, I'm going to right-click on it, hit Add, and now I'm going to add a new item. And from the new item dialog, we have a whole lot of things that we could create as new items. By default, we have class selected, and that's very convenient for us because we can name the file and then we get a resulting class name, and that's just saves a little bit of time.
Mm-hmm.
So for the name of this CS file, we're dealing with the game manager now, so it would make sense to name this file GameManager.cs. So there's our game manager. Click add, and now we have a game manager CS file residing under the classes folder. And if we take a look at the editor now, this CS file has been loaded into the editor, and we're looking at the code it contains. It contains a few usings, just like the program. It contains a namespace and contains the class that we...
Oh boy, this is where things are going to get really fun, and since I'm trying to really avoid any language lectures here, I have to kind of raise an eyebrow and do this carefully. Ooh, we have a namespace. Hyperion.classes. Very interesting. Let's go back over into our program real quick, and now let's take a look at the namespace there. It's just Hyperion. So remember, I said earlier that we've got these containers, system.collections, system.text, okay? These are namespaces. They're containers containing text, and you can see below, Logan has started one, namespace, Hyperion, and it's got code inside it. Now, granted, that particular one was set up for us by default with the project name and all, but it's there. Our code is being contained in that. Well, we just created our first class that we're going to be able to make an object from, and it's called the Game Manager, because we want to make that Game Manager object that we drew over there in Photoshop. Well, if we could jump back over to it real quick by just clicking on the tab, its namespace is Hyperion.classes. So the namespace is kind of like a virtual folder lower than Hyperion. Check this out. Let's go back over to program real quick, and I want to cut that code that we've written out of there, and I want to paste it over. So we'll just cut it. Let's go back over here. Now we're going to add our first method here.
So inside of Game Manager, what have we been talking about? Well, we've been talking about the title screen. So we'll create a method for showing the title screen and call it just that. Throw a few keywords down, and we'll have our show title screen. Let me catch the casing on some of this. So there's a method, show title screen.
No different than, as I said earlier, we've got tv.turn-on, tv.change channel, etc. This here will be Game Manager dot show title screen. So let's paste that code in there. Now there's a couple more things I want to do real quick, Logan, because in this particular case, this is kind of like the TV thing that we created back in the example earlier. Remember I said, let's pretend we have a TV factory out in the backyard that has some blueprints for a TV, and they can crank TVs out for us at will. Well, this is a case where we don't need multiple game managers. We only need one game manager. Remember, back over in our Photoshop document, we were putting an S after things that were multiple. Rooms, items. Game manager, we only need one. So remember I told you guys that word static? All right, well, let's use it, Logan.
All right, in front of class manager, we're going to change this to say static class manager.
Now, what's interesting about that is when the game runs, the game manager exists. Or when this program runs, the game manager object just simply exists.
Right, and this is a simplified description of static. We can go a lot deeper into how this works and what it means. But one of the upshots we get from using a static class is that we don't have to make a copy of game manager when we load the game. Because it's static, it will just be there and be available to us. And that's what we're trying to leverage.
Precisely, and you're going to find a lot of things throughout this very simple Hello World application that we're creating will be static because we only want one of them. And this is going to really impact the way you guys visualize object-oriented programming, because when we start getting into places where we can start using many instances of a class to generate, where we have basically a lot of objects, it's like, wow, this is so cool. I had one, we're working with it this way when it was static, and now I've got a whole bunch of them, and they all have their own identities and capabilities. How cool is that? So, right now, we're starting simple. We only need one game manager. It's static. But this does also change the way that we need to basically declare our method there. It's going to change just a little bit where we have to make sure it is static as well. Okay, so we've got this one method that belongs to this one object, the game manager. Okay, so all this is looking pretty good, Logan. But you know what? If we go back over to our program, our main area, and call on this, because that's how it all works. We basically we talk to objects and we call on their methods to perform an action for us. Just like the real world. We walk into our living room, we pick up our remote control, and we hit power on, which triggers the remote dot press button, which in press button, it checked and saw what button I pushed. Ooh, you pushed power on. And it shot out a signal to the TV. Now we have another object that received that signal, and it realized that, oh, he was calling upon my dot turn on method. So we need to talk to the game manager here.
Game manager.
Then he needs to hit dot, because what is it we're going to tell it to do? Oh, wait a minute. IntelliSense, which you guys have already seen like crazy. Remember, as Logan's been typing, this box keeps popping up, which is just absolutely fantastic. Microsoft has come so far with it. I mean, it does a really good job of helping you isolate things, find things you didn't even know existed. It just helps you by kind of saying, well, these are all the possibilities you could type next.
It's like your technical version of a palette. It's a very smart palette where as you start to type things, it's seeing that you're typing Game Manager. It's like, well, let's go ahead and show the programmer a whole bunch of things that are available in Game Manager, or
right.
that Game Manager even exists. So it's like a very dynamic palette. You start to type, a palette comes up, and if you want, you can quickly choose instead of having to type the whole thing.
Well, let's go ahead and try to finish off the command. It's supposed to be game manager dot. You can probably go just copy it if you want to, or type it out. It doesn't matter. But, yeah, the show title screen. There you go.
I was looking at the wrong part of the file. But
So
show title screen.
There we go. And terminate. So what we're doing here is we're telling the game manager object to show the title screen. And what that is doing is it's called to that object. Let's go over to game manager real quick. And it's saying run this code that is inside of it. So those two lines right there that Logan's slowly trying to, there we go, highlight. So it's telling it to run that. But we got ourselves a problem. Let's go ahead and execute this application. And check it out. The name Game Manager does not exist in the current context. Well, that's right. We can't see it. Right now, we're not using Hyperion.classes. We're not using that container of code. I can prove this to you. If we head back over real quick to program.cs at the top in the top tab.
The way I'm going to jump to that is actually double-click on this error, so it'll take us exactly to what blew up.
Very cool. All right, go up to the top to all the using stuff. Let's add one more line. This is a very quick and simple way right here. Using Hyperion.classes.
And you can see it exists.
IntelliSense, look at that. And there we go. So we just simply tell it. Now let's execute the program. And look at this. It looks just like what we had a few minutes ago when Logan simply added that console.writeLine code into the main method itself. So if he goes ahead and hits the enter key, it's going to close down because that was a line. And all is working great. Now, our preference in regards to organization, we're just going to keep everything inside the same namespace. In other words, we've got one giant Tupperware container that is called Hyperion. And we're just going to keep all of our stuff in there so that we can see everybody. Okay?
Right. The idea being that namespaces, the way they're kind of working as folders for us right now, where the show title screen is in a folder separate and below program, because program is just under Hyperion, whereas show title screen is under Hyperion.classes.
Exactly.
And without adding the references to each other, they can't see each other's functions unless they reside in the exact same
Check
namespace.
this out. Does that mean I have to using Hyperion.classes? No, I don't have to. I could take that out and fully qualify the name of my object if I wanted to. Go ahead and just take that whole line out. And then let's go down there to Game Manager, and let's go and type in Hyperion.
Yeah, hang on. Yeah, I got it.
Dot. Okay, now check it out. Classes from IntelliSense. Go ahead and select Classes because we know that's the folder. Dot. Well, it's already there. Look at that. So there, now it's fully qualified. This is its true name from start to finish. And we're able to find where that piece of code resides. It's residing inside the namespace Hyperion.classes, the object's game manager, and there's its method. So let's go ahead and run now, and you can see that it runs just fine without that other using in place. Again, it's too much. There's no reason for us to have to go through and fully qualify every single name that we end up putting up into different folders for organizational purpose. So what I want to do, Logan, is simply take out that Hyperion.classes real quick.
So this is going back over to Game Manager where we define.
Well, actually, real quick, go back.
This one.
Yeah, go ahead and take all that out. So to make this work, all we need to do is, as Logan was just now starting to show,
we'll go over to Game Manager, and now you see we've defined that Game Manager is within the namespace Hyperion.classes. We can change this. We can tell that it simply resides under the namespace Hyperion.
Yeah.
And now if we look back over at the program, you can see Game Manager now shows up as
green, but hit enter. Hit enter. Type game. You'll see. Hit enter. I got it.
You mean run or?
No, enter. And type game manager. You're doing the exact same thing. So, oh, look, there's game manager. Hit. Now just go ahead and, yep, dot. Oh, look at that. Show title screen. It's all there. IntelliSense is picking it up because it knows where it's at. It knows it's a possibility that we might be interested in. So I just wanted to point that out. So what Logan's going to do is just take the dot classes off so that we don't have namespaces that end up being several levels down and all.
Right. And now we're done with that example. That was, again, just showing what would have happened if we tried to access Game Manager and with it already being in the same namespace.
That's right. So for this program, this is how we're going to do it. That doesn't mean in the future that all of our namespaces will just be a single namespace like this. We're keeping things simple. Okay, so with that in place, we...
Just one thing before we continue. The reason that Visual Studio went ahead and added dot classes onto our namespace was because we decided to add things into a folder. What it was doing was trying to take that folder structure and represent that in the way the namespaces were laid out.
Absolutely.
And that's why it happened. If we had made a bunch of classes just at the root of our project, we wouldn't have gotten that.
That's correct.
But in this is kind of a special case. We want to use folders for file organization, but we would rather have our code in the same namespace. And those two things can be separate. As we saw, we deleted classes off of the namespace. Now we have everything in the same namespace, despite being organized into different physical folders.
Exactly. So Logan, here's what I'm going to do, my good friend. Watch this. I am going to come over here to Photoshop, and I'm going to say it's just very, very rough first stage of skeleton, but you have the game manager object there. All right, let's go ahead and jump back over, and what do you want to do next? Like maybe level? I want to get all of these checked off.
One thing, do we want to finish off the skeleton? I know we added one thing to game manager.
Yeah, we'll come back to it. Ladies and gentlemen, all we're going to do is just create the most basic structure of the class for all these. Then we'll come back and start worrying about putting what kind of methods appear in each one.
Okay, so if we move on to the next class that we need, that class is going to be the level class.
Okay.
To add it, we can go up to classes, our classes folder. We'll add a new item, and this item will be level.cs. Because we called the file level, and this was making a class, we've created a class called level.
Okay. Two things I want to see you do. One, take out classes.
So again, this all resides in the same namespace.
And number two is how many levels are we going to have in the game?
One of them. So this will be static. Like
all right,
so.
Beautiful. Okay, now let me go ahead. So this is a little game. We're going to trade off back and forth. Just so that I know, level is now complete. All right, so let's go to the next one, Joe. Okay, so now we're going to do room.
And again, same thing. We'll add a new item called room. And this adds our class. We need to take the namespace, make sure that it is simply Hyperion.
Oh, now this is interesting. How many rooms are we going to have? One? No. Our level can have many rooms, so we're not going to add static in this time, so that we can create instances of this class. We can make multiple objects that are of type room. So with that, we can go ahead and just come back over here. And rooms, with an S, is now in place. So let's go ahead and do our next one, which is going to be item.
Alright, so coming back to Visual Studio, adding another new item, this time item.cs.
Okay.
And the namespace, we'll clean that up. Now item, again, multiple items,
That's right.
So not static.
If we had only one item in the game, it would be a very boring game. So we're doing the exact same thing. So again, I'm just going to come over here. Now remember, we put them with S's over here to denote for us in our plan of attack for the objects we were going to create that these were going to be non-static objects, non-static classes. So that guy's in place. All right, so now let's do the player.
All right, adding another new item, this time an item called player.
See, guys, I told you I had a plan. Monkey see, monkey do. After a while, you're going to do this so much, it's going to be like, well, okie dokie, this is getting boring.
So, okay, class player, how many? Well, one of them.
Only one. And so, once again, we can go ahead and jump over here, and I can check this guy off. Wow, look at that. We're almost done with him. So the next thing we're going to do is go ahead and get our command processor in place.
So we'll add a command processor. Okay. And actually, I messed up on the name. I'm going to rename that before I go and create the class.
Okay.
And yes, I would like the references updated. So there we've got that. Because it updated the references for us, the class is also cased properly.
Mm-hmm. So let's go ahead and take classes out. And how many command processors do we want? Only one. Okay, so let's go ahead and jump back over to Photoshop real quick. And that takes our command processor and gets him out of the picture. So now we need a text buffer.
Alright, next class shall be text buffer. And text buffer, correct the namespace. How many of them?
Only
Just
one.
one text buffer. Static.
Okay, and we can go ahead and check that one off. And then the next one that we're going to want to create is going to be our text utilities, or text utils. All depends on how you want to call it.
I'll probably do text utils.
That's fine with me. I believe our crowd understands what we're going for here.
Text utils, we have our class, we correct our namespace. How many of them? One, so static.
Okay.
And we can check off
Alright,
text
so
utilities.
let me find my pen, and that leaves only one little special thing here, Mr. Logan, your directions.
So to begin with, up to this point, it seems like the same thing. So we go, we create a new, let's see, direction.cs file, we add it, correct the namespace. Now this one we are going to handle a little bit differently.
Okay.
Instead of making direction a class, I'm going to make it a struct.
And a struct is like a class. It's like a very, very lightweight class, if you will. It's probably all I want to say about that right now without it becoming too technical. Okay, so continue.
And yeah, that's, I'm just checking one thing, and yeah. So that takes care of direction. And we can check that off.
Okay. All right. So that puts all of our objects into play and our one struct. So Logan, at this point, what I'd like for us to do is we can go ahead and let's just come back to the game manager, since that's the manager. That's where the heart of everything happens. Now we're just going to lay out our framework for our methods. Just put in just the name of all of our methods for each of our objects and talk about what they're going to do.
Okay. So going back to all the files, and let's load up Game Manager, which is dropped off the edge. So Game Manager. We could maybe close some of those and go through them one by one, but this works.
This works fine.
All right. To rough all of these in, I'm going to begin before we even start laying the methods down, as I'm going to define this with a comment as our public methods.
Ooh, public methods and private methods. Interesting. We'll talk about all that stuff later.
And there are probably better ways we can arrange this, but we'll get into that as we have more of the contents of these classes put together. So just looking at the public methods for the game manager, what do we have after, of course, show title screen? Well, we have things like start game.
Again, this is just a rough skeletal outline. The two slashes in front of the word, that indicates that it is a comment, so it is completely ignored when the game is compiled and run. But we'll come back in and we'll address every one of these as we start to actually fill them in.
So that's...
So what's start game do?
Well, start game is actually rather simple. Its only job is to tell you what room you're in, because we're going to assume that the level's been created by this point.
Okay.
So we're going to basically display the level.
Okay.
Because otherwise no command has run yet. There's been no reason to show the level. So we're going to have the start game actually show the level itself.
So the level's been initialized, as a matter of fact, unless I'm just not with it all the way. Back over here, start game resides right down here. So at this point, the level's already been initialized, and my color, I got to actually be on that level or layer. So start game's right there. So by the time we get here, we've already told it to show the title screen, initialize the level. So now its job's going to be start the game.
Yes.
Okay, let's continue.
And the only other thing that it's really going to do internally is make sure that all the text gets shown to the screen. It's more of an internal thing. So really, start game's job is to kick off the display of the level.
Okay.
That's its job. The next method is endgame. And let's see, well, simple enough. Endgame's job is to mark the program as ready to quit, and then show the final ending message.
Okay.
And after it shows that message, it will prevent any further input so that you can't accidentally bump a key and drop out of the game without getting a chance to read your ending.
Okay.
Next method is apply rules.
The heart of the game manager, in essence, because apply rules, this is where we're going to basically go in there and put all of our very linear, very straightforward code, if statements, if you will. That's just going to say, if this condition is met and that condition is met, win the game, or kill the game, or add a new item to the game, or add a new door to the game, etc.
Right. Its job is to simply look at the player, the rooms, and the items, and see if they are arranged in a fashion that should trigger something special, like an ending or a death.
Now, this is something that we would actually handle differently. There are several things in this game that we would handle differently if we were coding this for production and then released to the masses. Right now, remember, the goal of this is a Hello World app, and how many times have you seen a studio sit down and program a Hello World app and, well, market it? It just doesn't happen, and we're not trying to make something marketable here. We're trying to give you an experience of doing a full game from start to finish. So this, I just wanted to point out that when we get to coding apply rules, Logan and I are both not fans of this method, but it will work. It'll work just fine. It's just not, it doesn't really follow the whole object-oriented paradigm, if you will.
Right. It's basically, it would take more time to go in and make all the objects actually cause interaction with each other.
Correct.
So instead what we'll do is we'll jump back a level looking at all the objects and just say if the pieces are arranged like this, we'll call that one state, like an ending.
Right.
And if the pieces are arranged like this, that's a death.
I can promise you guys right now, some of you might be saying, I don't understand what you're getting at. All the stuff I'm saying is going to slowly start making a lot of sense. Okay, so really, that pretty much wraps it up for the game manager. So we have a very, very rough structure in place. We have the method names. Now, there's more information that we're going to need to add. Like you see with the method above, the show title screen, it has public, static, void, and we'll talk about all that stuff a little bit throughout this program and then in much greater depth in other programs. But anyways, we're going to need to be adding a lot of that stuff into these methods. We'll come back to that. Right now, let's keep it very focused. So let's go ahead and move on to our next object, which was level. And with level, we've got two different methods that we need to get in place.
The first method is initialize. And initialize, the purpose of initialize is to create all of the rooms in our level. It is to create, or it's used to create all of the items, place those in rooms within our level, and finally to take the player, set its location to reside within one of the rooms. So in essence, placing the player physically within one of the rooms.
And let's jump back over here to our black and white board, ladies and gentlemen. Initialize level, look at that, right there. And we've all seen show title screen. These are actual methods from inside our game. Okay, that's all. So initialize is actually very straightforward, very important, obviously.
Build the level, place the player in the level.
Now, don't let this next method that Logan's about to put down confuse you, because he just used the word, which made me cringe a little when he did. We've got build level.
And the idea there being that initialize is something that makes sense to happen when the program begins, that we initialize the level itself, set it up. Build level is what will actually arrange the level together, and the idea of having these separate is initialize is something that happens at program start. If we ever extended upon this game and wanted to have level loading code, where you could load a level after you've been playing or at the end of one game and begin another, it would make more sense to call a build level. So we finish one game, build a level again. Finish that game, build a level again.
So for simplistic purposes, we could have kept everything that's in build level inside of initialize. But you are going to find there are a few places throughout the code where we are thinking about some simple expandability. And here is one of them.
Right. And really,
that pretty much wraps it up for the level object. So what that's going to do is move us on to the next object, which is room. And room gets a bit heavier with methods. It's got quite a few methods that we're going to need to add.
Okay, so let's jump over to room. And
let's go ahead and start with some comments for our public methods, because these we've got some public and private methods.
So our public methods and our private methods.
I'm going to put that space in there just so that,
just for consistency.
All right, so what's public? We're going to go ahead and start with describe being the first one. Very important. When we walk into a room, we sure are going to want to know what that room looks like, and the level designer is going to come up with a description of the room. Starting to put the pieces together, ladies and gentlemen? That's what describe's going to do.
All right, so next we've got show title. Show title.
Just like described, you remember you guys saw that we were able, when we were playing Hyperion, we were able to walk into a room and say, where am I? And it just gave you a very brief, this is where you're at. Well, that's the title of the room. So there you go. Show title will show us the title of the room.
All right. Next method shall be get item. And what get item is going to do is it's going to allow us to ask this room if it has an item and ask by name. That means give it a textual name and ask the room if it has an item matching that name.
And you guys have actually seen this already. If I come all the way back over to here and we jump up to this particular layer, look at this. We're going to ask the room, does the apple exist? Does it exist? Nope. Does it exist? No. Does it exist? Yes. So here we are getting an item from a room. So I just wanted to jump it back over there real quick to remind them.
Right, that's what that's actually going to be doing, what we'll need to be concerned with when we flesh it out. All right.
Another very important one. With a room, we need the ability to add exits, because remember we said we contained a list of exits within the room. So we need a method that allows us to, on the fly, add new exits to the room.
And along with that, we also need the ability to remove exits to make the game more interactive. If we wanted to lock or close a door.
Yeah, let's say we opened a teleporter somewhere, then we did something else later on that closed that teleporter. That teleporter was an exit. Okay, so next, can exit.
And what this is going to allow us to do is to ask a room if we can exit in a specified direction. We can get the room that we're in and ask that room, can we exit to the north? When we ask it this, it will look at all of its exits and see if it has a north exit. If it does, it will return that true, yes, we can exit, or no, we can't exit in that direction.
Right.
And this will be the basis for whether or not, or how we navigate through the level, whether or not we can exit from a certain direction.
Very nice. Now let's go ahead and jump down to some of our private methods real quick.
So, beginning the private methods, we have get item list.
So, for the room, it just needs the ability to, well, get the item list.
Right, to go, and this will go along kind of with describe. Its purpose is to look through all of the items in the current room and generate a text display for each item. Generate a textual list of everything that we have that can be displayed.
Right, and you guys know why this is important, because surely you remember the game. We actually showed you where this was more or less being used.
Exactly, and that pretty much looked like a list. It was a text list of items.
A list of items in room, and then you had a vertical list.
The next thing is very similar. It's get exit list.
Exact same thing once again. It's going to go through, read all the exits, and then just print them out for us. So again, go ahead and click on Hyperion. I think it's still up.
It should be over here.
Yeah. So there you go. You're looking at two lists right there. Items in room, none. So our item list contained nothing. Possible directions. We have east and west. Our exits list contains those two things, east and west.
So there's a little glimpse of the future. We have our get item list, which we can see here, and we have our get exit list, which you can see below it.
Okay. And there's one thing left, which is going to be this is more so not for gameplay. This is more so for us, that as we are going through and creating the game, we need some debuggability. And we don't want to sit down going through a level designer's map trying to figure out if something's broke or not. We don't know where we're at. We don't want to have to start physically mapping it out by hand, right?
Right. We'd like to be able to look at what the game is showing us and then reference that back in the level designer's original data.
Exactly. So we're going to go ahead and create a get coordinates method, and this will be our own little private method that we can use whenever we want to get the coordinates for the room we're in. All right, so that pretty much wraps it up for room. Now let's see, methods for the next thing that we were working with was item, and there are no methods for item. That's not what item's all about. Item's just an item. Unfortunately, though, in the future you could expand it so that it had methods. If the item was a VCR, maybe it had the ability to play tapes and all. I don't know, I'm just throwing stuff out there. But there are no methods for items. So moving on, the next one that is going to have a series of methods is going to be the player, because obviously the player has all sorts of actions, verb-like things it can do, such as move.
So we've got our move method, and move's purpose is to go in and find, first off, what direction we were trying to move in, ask the room we're in if we can move in that direction.
Which we just
and
saw
if we can indeed, yeah, exactly, we actually laid that out in the room. And if we can indeed move in that direction, if room will allow us, we take our position and we advance it based on the direction that we're moving in. If we're moving north, we might advance our Y direction. If we're moving east or west, we might advance our X direction.
Okay.
But once we've advanced our internal direction, we then again look up what room we're now residing in and describe it, and so that we visually see the result of moving to another room.
Okay.
Next we've got
Pickup item.
and
Again, a very important thing that a player needs to be able to do if he's going to have an inventory and items that he can, well, at least pick up off the ground. So pickup item is just that.
Right.
Check. Go ahead.
That's a check to see, all right, I'll look at the room we're in. Does this item exist? If so, all right, let's take the room or take the item out of the room and place it in our inventory.
And it's a little more sophisticated because
Right,
how much does it weigh? Is it overweight?
There's further checks that take place,
Sure.
but that's the general idea. Take items out of a room and place them in our inventory.
If we can. Which brings us to the next one, which is simply going to be drop item.
And which is kind of the reverse. Take items out of our inventory, if they are indeed in the inventory, and drop them into the current room.
In other words, take the item out of the player's inventory list and drop it into the room's item list.
Exactly. All right, next we've got...
Okay, so after drop item is going to be display inventory, because if we can pick things up and store it and take stuff out of the inventory, we're obviously going to want to be able to display our inventory, which is going to do just that. It's going to display our inventory as well as show us how much weight we have available.
All right, moving on, we've got...
The next one's going to be get current room, another very important one.
And this is a way of making it so we don't always have to deal in coordinates. As you've seen from the grid layout we had drawn in the planning stage of the game, and in the idea of rooms themselves, rooms are arranged in rows and columns, X and Y. And that means our location is going to define what room we're in.
Right.
What get current room's job is to take that location, do the lookup, kind of the trace that we had done on paper, and bring a room back from that. So that way in code, we don't have to worry about X and Y. We can just say, all right, player, where are you at? Oh, I'm in this room, and return the room that we're currently in.
And then finally, we have get inventory item.
And the purpose of the get inventory item is to be able to take in a textual name of an item and see if it exists in our inventory list. If it does, return the actual item that goes along with that textual name.
Okay, that's going to pretty much wrap it up for the player. Again, I mean, it's not super method heavy, but it's player and room are our two heaviest objects carrying methods. So from here, let's go ahead and move on over to the command processor as we continue just putting a very rough skeleton in place.
Okay. So first method that we have in command processor is process command. And the purpose of process command is to take in the line of text that was entered, break that up, and divide it into two pieces, a command piece and an arguments piece. We then take that command piece and decide which command it is, if indeed it is a valid command.
Right.
If it is, then we do something based on that command, possibly also using the arguments along with it.
Okay. Such as move north.
Right, where we have move as the command and north as the arguments.
And next we've got show help.
Space that. And show help is very simple. It's just used to show a help screen. Its job is just to show a list of all available commands.
That's right. All right, very cool. Okay, so that's pretty much going to wrap it up for our command processor. Again, as you notice, for the most part, everything's been very straightforward. You know, some people may be just slightly confused with, you know, getting items, this, that, and the other right now. That's okay. We've got to start hooking all this stuff up. Again, we're just putting a skeleton in place. So let's go ahead and move on over to our text buffer. Remember, that's the place where we're going to be storing text, where we're getting ready to display it, which means basically, if you think about it, so here's a good example. A lot of people might be wondering that are completely new to programming, all these cool methods that we're coming up with, these different actions, how'd you come up with these names? Well, we sit there at the very beginning in the planning stage, and we did just what we did earlier in the Photoshop stuff where I was going through and drawing things out. We just simply talked about it. What does the player need to be able to do? What does a room need to be able to do? And we simply broke the actions down. Of course, I didn't want to write all of these things down one by one in Photoshop on the whiteboard because that would have taken forever. But let me give you guys an example of working through a problem like that. We determined earlier in the last lesson that we needed a text buffer, a place where we could start dumping all of our text as we prepare to put it out on the monitor screen for the player to read. Well, let's see. What kind of methods would that require? Well, let's think about it. We need to put stuff into the buffer, and we need to display the buffer. So there's two methods. How about add, and that'll be the name of the method that will add to the text buffer. And then how about display, and that'll be what will be responsible for actually displaying it out to your screen.
And that works just fine. So let's throw those comments down and note those methods.
So did it have to be called add? It could have been called add text to buffer. You know, it's up to you. You're the programmer.
And we also had display.
But again, these are methods, so you want to write them out as a verb, or at least try to.
Right. So add is something we can do. We can add to it, and display is something we can do. We can display, which means put the text on the screen.
Absolutely. And so, of course, with the text buffer, that led us over to text utils, or text utilities, where we had three different things in there. I want to go ahead and start with extract command, then extract arguments, and then finally the big one at the end. You know, as Logan said a second ago, when we're getting that input from the player, they're going to type something in, right? And we're just going to receive this big string of characters. And that string of characters may contain a command and some arguments. An example would be move being the command, east being the argument. So we need to be able to take that one string of characters and extract the one word, which is the command, and then the second word, which is the argument. So we need methods here that will basically isolate that functionality and take care of doing it for us. And then finally, we've got one more text utility. This is a more complex one. And this one here is called word wrap. And its purpose is just to make sure that we start a new line before any word gets the chance to get broke at the end of the console and start on the next line. It makes reading a whole lot easier.
Right, because the console wrapping is one where it will break words apart in order to wrap them. And for readability's sake, we'd like to be able to handle word wrapping ourselves and have words held together as whole words.
Now that really does get outside of the scope of this, what you guys are trying to pick up here. But I want you to watch it anyways because this game did need it to make the game more pleasing to play. All right, so with that out of the way, that takes us all the way back to your direction struct, where you've got one thing you need to add in there.
All right, let's take a look at direction. Inside of direction, despite it being a struct, there is in fact one method we're going to place inside of it, and that is valid direction.
Remember, like I said, the struct, a particular type of data, it's like a very lightweight class, so it can indeed have its own methods, and here is an example of adding a method to it. All right, so with that, Logan, we now have all of the objects created that we specified back during the design phase of this, and we've gone in and we've added all of the functionality that each one needs to have, at least just the name of the functionality.
Right, we've noted all of the functionality within each of the classes.
And so I think what we're going to do next, in the next video, is we're going to go in here and start putting the data that each of these objects can store. Like with a player, he's going to store something like his position in X and his position in Y. We'll start getting all that in place, and we'll slowly start building this up, and hopefully things will become more and more clear to you guys. So with that, is there anything else you want to add to this one?
I think that covers it. Looking over the notes, there's just one tiny thing we can correct with direction, just a little syntax thing. That in our code, it's a public struct. Again, not even getting too deep into what we're doing there, just getting all these ready to be used.
Okay, so with that, that is going to wrap up this video. Follow along. It should be able to execute just fine right now.
Right, because we haven't actually defined these as real methods. They're just sitting there. Again, we didn't actually add functionality yet. We just we wrote notes for ourselves to tell us where the functionality goes within these classes.
Precisely. So follow along, and if you haven't, back up, follow along.
Matter of fact, with that, I'm also going to save, because while we started the project, it hasn't put this on the hard drive yet. So we're going to allow it to use the project name for our folder, and save it under its current projects folder.
Okay, sounds fantastic. You guys do the same. Make sure you get all the way up to this point right here. I promise you it'll have a lot more value if you follow along. Even if you're not 100% sure exactly what it is we're doing, it's going to start making more and more sense because I'm going to continue talking. So with that, that is going to wrap up this video. We'll see you in the next video lesson.